Today we are going to explain about the truss analysis and design by Staad. So obviously it is also one kind of steel structure. So we can provide with the wood, some other material also, but we are designing today with the steel. So maximum it is used for the bridge structures or kind of the roof top structures. So mechanical sheds, some other places. So we'll go for that one. New project, truss. File name will be truss, and length units will be meter, force units kilonewton. So we are going for the open structure which are finish. So we'll get some kind of the prototype models here. You can see here. The starting one will get the truss models. So in that one we are taking that one hoi roof. So we'll get the measurements. So making width is equal to 0 meters. So length 10 meters, height 3 meters. So minimum dimensions we are providing, as you can see here. Okay, we'll go for the transfer model S, and you're matching the structure with the snap node beam. Click OK. The first step is geometry. By using run structure wizard, it automatically finish here. You can see the dimensions. So after finishing up the step 1 geometry, you'll go for the second step, general property. Geometry with the help of open structure wizard, or it also called as a run structure wizard. That one we choose in the hoi roof. The next step, go for the general property. Nothing but we have to give some kind of material and thickness here. For the geometry below that one you can see in the page control, general property. We already discussed in the tower. For steel structures we are choosing the section database, and that one Indian. So we are giving section database. For tower we provided the channel shape, and this one we are going to provide the angle shape. So we are giving that one section database, and that one Indian angle, that we are providing single section 60 by 60 by 10 value. So the measurements of the channel, that one is structural steel we are providing it one, not the mild steel here. Structural steel, give it add, the single section only, add and close it. I'll assign to view of this one. Yes. So as you can see the 3D rendering here, how the angle shape will be looking like that. If you tilt it lightly on the screen, that you can see that angle shape properly. On the edges it will be very clearly visible there. So we'll close the 3D rendering view. We'll go for the next step. Geometry is finished, property finished. We'll go for the supports. So we are going to create two kind of the supports. Up to now we given the fixed support. So we'll go with the fixed and pinned support also. So in the steel structure, fixed means welding connection, pinned means bolted connection. So in the truss, one side we are giving fixed, and this side we are giving pinned condition also. Pin add. So we are taking the first one, fixed support, taking use cursor to assign option, because we have to give particular node there. On the one edge fixed, other edge we are giving the pinned connection. So supports is over. We'll go for the next one, loads and definition, load case details, add. So here also we are not going to provide the live load actually. So we are providing in the live load in the minimum case of nodal load, but that will also coming to the consideration of dead load only. So dead load, case details, add, loading type, dead load. Second one, live load. In the dead load, I'll click add, I'll get a sulfate as usual, y minus 1, close it, give as an interview of that one. I'll choose the live load next one, click on add, I'll go for the nodal load. So if we are giving the minimum load, just -3, -5, it's up to our choice, give add, close. So I'll go for the use cursor to assign, Fi, use cursor to assign. Where we are providing means maximum load. When any strut is meeting with the purlin or curd, that point we are going to give the load distribution maximum. So that point, those are the points where the strut and completely curd are meeting. So loads are finished. We'll go for the analysis print, no print, add, close, and we'll go for the design. So in that word design, steel structure. So we are going to choose a steel. Under current code as usual, IS 800 LSD. LSD refers to limited design here. So these are the process completely similar for the steel tower and truss. Design parameters will be steel IS 800. So we can provide the design parameters here. FILD, yield strength of the steel, and the commands will be check code. You can see the first one will provide the defined parameter FILD 415,000, add, close it. So we'll go with the commands, check code, member takeoff, next one takeoff. So these are the commands must and should we give for the steel structure. Check code, it will check the IS code. Member takeoff, individual cost of the each member. Takeoff for the total cost of the structure. So it will give you all the things are to assign to view. So after completion of the total design, we'll go for the analyze, run analysis. So the program is running, as you can see 0 error, 0 warnings. So we'll go for the view output file. This is complete procedure in the commanding program Staad editor. It will be the steel design. So takeoff of the total cost. So I mentioned in the kilonewton 4.858. The individual member takeoff, member things. So we can make the estimation of the total cost of truss also. So I'll check the steel design of each member. As you can see that angle shape. So it's very clear. For the strut or curd or purlin, for every member it is provided in the angle shape. So depending on the structure designing, they will mention the steel design, it will pass the structure, code result pass or fail. If any failure, we can redesign again.